I welcome you all for today's session, that is day 3 of our FDP. And our today's resource person name is Ankit Kumar. And I will just, before he starts the session, I will give you a brief introduction of him. So Mr. Ankit Kumar works as an application engineer for MathWorks at Design Tech System Private Limited, Pune. In this capacity, he works with academic institutions to efficiently use MathWorks resources in research and education. His area of expertise is model-based design, simulation, and electrical vehicle. He has over 11 years of experience working as an academic researcher and assistant professor. He has published over 5 papers. Ankit holds a bachelor degree in electrical engineering from Pune University and master's degree in control system from Pune University. So I welcome Mr. Ankit Kumar for today's session, and not only today, he will be coordinating for the next 3 days. So I welcome you, sir. You can start the session, sir. If you
Hello?
can hear me.
Yes,
Yes,
I'm
Mr.
audible,
Ankit, you can
Deepak?
start. Yes, you are audible. Yes.
Okay, fine. Okay, so I'm sharing my slide. Yes, my screen is all visible.
Yes, sir.
Fine.
Yes, sir.
I'm audible and my screen is also visible. I expected that. During my this 1.5 hour session, if my voice is not audible or slide is not visible, I'm continuing speaking, then please let me know to the chat or the WhatsApp. Okay, this is my organizer. This is my request. Okay, so let me start. This is the third day of the 5-day FDP sessions organized by the Bharati Vidyapit Deemed University ETC department. Okay, so I welcome you all for the joining me today, and hope during these sessions you will get to know different things, different tools. Uh, what are the things we can do? Okay, yeah, I'm audible now.
Yeah, you are audible.
Yeah. So during this today and day tomorrow and day after tomorrow also, I try to more focus on the MATLAB as a tool we can use for this artificial intelligence applications. I think today most of the participants from the PhD pursuing the PhD background and others also. Okay, so I'll just make a heading here, the deep dive into artificial intelligence application workflow using MATLAB. So, and then I have make the step-by-step introduction with the MATLAB. Okay, so by considering that, all of you get to know MATLAB, some things you know, some things you get to know new, and try to manage the new things. Okay, so let me start as the organizer has already introduced me. So this is me. Okay, so this is my subtitle for the today's sessions. This is a experimental learning because MATLAB is a tool that you can use for the experimental learning. Okay, so let me start the things. Today we have two things with us, MATLAB and Simulink. This is a two thing with us. These are the tools and how we can effectively utilize these tools to fulfill this workshop. Basically, this workshop, FDP, short session or STP is generally organized to get to know the different workflow, different things. So MATLAB and Simulink, I suppose that this is not a new to you. All of you have well known you have used in undergraduate and when you are postgraduate, or if you are pursuing the graduate and postgraduate as well. Okay, have your PhD. This is not a new thing to you, but from the last several years, the MATLAB Simulink has revolutionary changes with their different workflow, different capabilities. Okay, they have enhanced their toolboxes, libraries has been added, different workflow, whether you can start from the data analysis part, then you want to develop the different apps, okay, parallel computing toolbox when you are handling the large data sets, okay, on the simulating robotics, every applications we can implement most of from now, from the starting from the simscape we have, the simlink we have for the physical modeling robotics, okay. Now the buzzword is AI here, okay. So title we have given the AI, so how we can leverage this MATLAB and simulink for the AI and others applications also, okay. So this is the two tools we have, and I hope so during this during today sessions, you you all of you well known then how to effectively utilize the MATLAB. Okay, this is the my main agenda for the today sessions. Okay, so all of you are the part of the BVCOE. We already have a campus-wide license. So let us start that. Today's agenda is summarized in this diagram. Okay, now see that this is a diagram. Let us take pictures, and now I have given a 5 pictures over here. Okay, so what is core of it? The core of, if you find out, the core of it is nothing but the pixels. Pixel is nothing but is a number in the form of matrices, or maybe the RGB format, or whether the grayscale format. Okay, so when I say RGB, earlier it was just a one image for the common people. For the engineers, it is a for the researchers, it is a just a matrix of numbers. After matrix of numbers, you have to analyze the things with these numbers, and for the analyzing the things you require the MATLAB. Okay, so MATLAB matrix laboratory, I think all of you know. I have just given you a diagram here, so separately RGB color they have divided like that. So these are the things I require for the resize, pre-processing or thing, or reconstruction uh, of the images can be easily done. You can find out the similarity between the two images. Okay, so degree of similarity. You can analyze the by the pixel. You can analyze the depth of the sand or depth of the Amazon Valley. Okay, if you have some historical data with you, let us suppose you have historical data of the Amazon Valley. Okay, uh, uh, through the height you have taken a picture, or let us suppose take the example of the your Bharati Vidyapeeth campus itself. Okay, so starting during the starting time, the maybe the greenery will be very high. We have taken the image in that. Then later on, you have taken 2000. You have taken one image, top view of the your campus. Then after that, you have taken another image in 2004. Historical data I'm talking about. Then you have taken the data after the again subsequent four years till 2016 or onwards like that. Okay, so you have to calculate or you have to analyze that, and each 4 years of the interval, how much greenery has been uh, degraded of the any area I am talking about, especially how much, because urbanization is increasing, so it will impact on the greenery of the any river valley or Amazon Valley. This is one examples are very well examples are in the MATLAB it is written. So you can calculate with the pixel value. You can calculate that the how much in each year the in each year how much the plant degraded. Okay, so that is a computational power. So with the four images, we can calculate the how much degradations happen in the any landscape. Okay, let us take the example of the landscape is like Amazon Valley. Okay, so in 2000, of course, around the Amazon river the greenery will be high. Then 2004, of course, it will be less, and subsequent year, and it till we have taken a data and the 2016. So you require one tool that such a things analysis will give, and the MATLAB is the best solution for you. Okay, so what are the things we can do with the MATLAB? Of course, everybody know programming platform designed for the algorithm development, data analysis, visualizations, and numeric computations. So we can do analyze the data, develop algorithms, create AI models and applications. And then if you work with the Simulink, then you have a model-based design, block diagram environment in the Simulink. We can analyze the dynamical systems, whether in the MATLAB or the programmable platform. So these two fundamental tool you have, and then others add-on products we have, like image processing, and then we have a statistics, machine learning, deep learning. Then you have a UAV toolbox where you can make a drones, okay, unmanned aerial vehicles. Then you have signal processing, then control system design with MATLAB, like that. And other things are there, linear algebra. So that thing I will tell you. So these are the add-on products. So along with the MATLAB and Simulink, you do it will help you for your work. So yes, of course, I already explained the Simulink, that is a block diagram environment to design Simulink multi-domain system. Like let us take the example of the motor. Motor is a electrical device, but along with that, the mechanical part is also there. Then they have a thermal analysis is also there. Then we have a then others, the multi-dimensional analysis are there. That then you have a base suit tools is the Simscape. Simscape. Okay, you can use Simulink and Simscape both together to do this such type of analysis for making of the BMS, battery management system, or design a electric vehicle design or motor design. Like that, you can use the Simulink and Simscape part. Okay, so these are just I'm highlighting the tools capabilities. Okay, that will be used for the model based design applications. Okay, so you may be aware of this. With this 15 dots, you can evaluate the whether the person is the man or woman, or whether it is nervous or happy, like that. This is the I have taken this user story from the biomotion lab. Okay, you may search it, Google it, and you may get the details, like for the analysis as a MATLAB users or Simulink users, what is exactly this. Okay, this walking this person is walking on the street. So it's nothing but just our Fourier series. Okay, so can humans determine the gait and gender other humans just by watching them walk? Even by the help of this analysis, you can develop whether the person is women when these 15 dots. So for more details, if you click over here, user story or the biomotions lab, you will get the very good idea. Let us see that. Okay, so I have just highlighted here. This is the 15 dots. Okay, so this screen is visible now. So just see here. So I'm just highlighting that this is just a Fourier series, and from here we can evaluate the Eisenhower. Okay, so this is a one example, very famous examples. So motion capture, you can how to implement this part. So Kleb Moller on mathematics and computing. From that you can calculate the typical SAD, Hassel, or Gretel. Then is a walking or it is a standing, hope strides way. You can even identify the gender also depending upon that. Okay, so this is also a very good example, and codes are also ready, so you can use it for your own work. Okay, so this is a one thing. Yeah, so it's okay now. This screen is visible now. So this is one example where means I'm trying to say is that, this is just a mathematics where you can implement these applications very easily. This is another story. This is another story developed by the author. Is a very famous two-wheeler company. It's developed by IIT Madras pass out students. Okay, so they have used our tools for making of this model-based design. Okay, so Athar has developed the very intelligent two-wheeler. They have used the MATLAB Simulink tools. And what was the challenge before the Athar as a startup company? They have a challenge. They have challenge is to design to produce India first intelligent electric scooter. This was the challenge. Okay, so how to do that? So
Hello, sir. Your sound is not audible.
I'm not audible. Okay, fine.
Sir, audible, sir.
Audible,
Audible.
audible.
Okay, fine, fine.
Hello, sir.
Thank
Are you talking anything?
Yes, madam. Sir, voice is audible.
Okay, thank you. Madam, kindly check this other energy develops electric two-wheeler like that. So how they have developed, there's a well story is there. You just search it, other energy, and they have developed with the help of model-based design, simulate and optimize. They have generated the very good model-based their model of their two-wheeler. Okay, they have what they have achieved. They have achieved the testing time with the reduced by the 50%, and they have very fast developed the prototype system. These was the two gate achievements through the model based design with the Simulink. Okay, it just for the your yeah, these are the things can be developed with the MATLAB. Okay, yeah, these are the things where you can find out these applications: aerospace, defense, automotive. In automotive electronics, aerospace and defense, now you are using the UAV applications, the drones applications, a very emerging and cutting edge technology. Okay, I'm observing that the next year, or maybe the in the upcoming years, the drone will be capture the very good position in our day-to-day life. Okay, they have already captured in the rural area where the hospitals to delivery of the vaccinations and the blood samples for surveillance. For the civil engineering, they are using very extensively drones data, like the flight log analysis data and all those things they are using in that area. Aerospace defense. So you can simulate the UAV model in the MATLAB easily. And other things are already there. You might be know very well in the biotech and pharmaceutical industry also using the MATLAB for their DNA analysis and the and that part. Okay, so and we are using in electronics and automotive the different applications. Okay, we will find out. And these are the yeah companies which are our customer. They are using it. Okay, now the main focus part is that I have already told you you have a MATLAB and Simulink with you. Okay, if if you are the students or you are the research scholars and you have newly joined, if the faculty member those they might be no, and some other also. So you have a campus wide license. It is a all the toolboxes which you have. Okay, one you have access to the MATLAB grader, all the self-paced courses which is also available free of cost to all of you. All the faculty member, staff, students, they can use in the three places. Okay, they are used MATLAB tools in their own laptop, their own desktop, on their mobile also. Okay, so in three places we can use it. You can use it on the downloaded version or also online version. Both the way you can use it. Okay, you can use it anywhere, anytime on the network, of the network. Let us suppose the conference you went to the Delhi or Mumbai, or you, even though you go to the outside of India for the, any conference work or presentation, you can use it there also. Okay, so just you need the one university provided mail ID. That's all. Okay, just you have to create your account and you have to start using it. That's all. This is just a slide I have added, that sir where to use this MATLAB. You are talking about this capabilities and how to use it. So this is the answer for that. Okay, so you have a university lab computer and use online access, personal computers. You can put a 20 GB space is available for you. You can store your .m file, .mlx file. Then you have a more than 50 courses which is a self-paced online courses which is available for you. You can make a practice, and in these sessions I am going to explore some of the self-paced online courses. Yeah, how to connect low cost hardwares. You can connect it. You can deploy on the HPC or clusters. That can be also be done. Okay, yeah, I've written anytime, anywhere access for faculty, staff, students. The MATLAB Simulink, they can use desktop, online mode, and mobile. Okay, so these are the things we can use it. MATLAB, you can access the MATLAB from here. Okay, and you have a 20 GB storage as I mentioned earlier, MATLAB drive, and where you can store your all work. Okay, so now connect the MATLAB Simulink to the different hardware Texas instruments, Arduino, Raspberry Pi, NVIDIA, GPU. If you want to deploy the things, that can be also done. If you want to interpret the Python with the MATLAB or MATLAB with the Python, that can also be nowadays. Now it is a very, you can access it. Okay, even though the deep learning model can be directly imported to the MATLAB. And others like Keras or other things. The pre-trained models are there. Okay, so here the things are there. Means I'm talking about the, you can connect the hardware also. So this is the page. If you are the students, then just note down the MATLAB and Simulink challenge projects. If you, with this title, if you search on the Google, then you have a list of projects are available. Okay, if you are searching a project, if you are the faculty member and want to give the some new topic to the your students, or you are the PhD scholar looking for some content, then you have a very good, this is a page where you can find out on the 5G, artificial intelligence, big data, computer visions, robotics, so renewable energy. And there's some our team will posted the areas where you can find out all the steps, what are the different tools are required to implement this project. Okay, and but only the project is not there, but steps are mentioned there. So how to do that? Okay, so this is the page. Just you have to type MATLAB and Simulink challenge projects. That's all. You will get a link, and you also get the GitHub link. Okay, some of the executable projects are available over there, so you get the idea how to implement the projects and all those things. Okay, so I highly recommend the students and the research scholars, please visit this page to explore further. Next. So this is the page. If you are uh, not just till now you are not able to access the, you have not created the MathWorks account, then you, this is the web page uh, where you can, this is the web link. Okay, so you just go to this page and just click over here, and now you are able to access the MathWorks account page. And you are, if you mobile is if not accessing through your mobile phone this webinar, so then try to do just take the 2-3 minutes to do these tasks at the moment when I'm speaking. Okay, so if you scan this also, you are able to reach to this website, and where you can create your account. Only condition is that you have a university provided mail ID. This is the only condition, like a BVCOE, whatever the Bharati Vidyapit account is there, so that you have to require. That's all. Okay, so this is a thing which you know. So if you have your university provided mail ID, then just at the moment create your account. That is also very important part to complete this three remaining days FDP. Okay, because I give you lots of tasks, I can summarize so many things. So for that purpose, I require this MathWorks account. So at the moment, take the 2-3 minutes and do this task immediately. Okay, those who have a university provided mail ID, Bharati Vidyapit. If you're outside of the this university, means then if you have a campus wide license in your campus, then you can use it your own mail ID in your college event, like that. So this is the mail ID. If you already created, then well and good, no problem. We'll move ahead. Yes, everyone, just take a 1 minute time and just complete this task if you are new. Yes, yes, everyone. Anyone created, or just put in the chat box, so I also get to know. So how many students have created, or if the research scholars are created, like that. Okay, fine. Uh, Let us move further. So these are the steps. These are the steps you have to follow. So step number 1, just official email ID. You have to go to that link and just provide the email address. Okay, and then the location you have to provide India, and base describe whether you are the student, research scholar, or faculty member. You just select from the drop down menu. Are you at least 13 years old that you can just click it and create one? Then you receive a one email with the name of service in your mail ID, in your inbox. Okay, so just click it and fill the further details. Okay, like your name, full name, and other things. And then when it will be successfully created, again come back and then log in it. That's all. So this is the complete step 1, 2, 3. I have just written here. So this is part is really important to make this FDP more realistic, or the hands-on exercise I want to give you. So that is a very good. Okay, fine. Everyone created. Just reply me. Just reply me on the chat box if you are created your account. Okay. Okay, fine. So I'm
Hello, sir.
now. Okay, if you are created, then it's well and good. Now I'm coming to the opening of the MATLAB directly. Okay. So this is a this is a MATLAB how it's look like. Okay, this is the startup page. Here you have a three options on the toolbar. This is a home, plot, and app. Okay, so here you have a workspace. Here you have a current folder, and I think that part is already you know very well. Okay, so here is the command window. You can customize from here. Layout, go to the layout. As per your wish, you can customize whether you want only command window or the like the script or anything or .m file like that. You can go default 3 column. You can go there. Okay, here is the add-on options. Sometimes you require the certain support packages. Okay, so you have to click on the get add-on. Okay, like when we talk about the deep learning, then there is a certain support packages you have to download. Okay, so you have to just go to the get add-on and like that you can read. Then here you get hardware support packages. When you interface with Arduino, Raspberry Pi, then here support packages you have to download from here. Okay, so these are the things here. Home, plot, tabs by default. Let us pass the first command. Let us understand the first command, VER. Okay, once you pass a VER command, then you saw that the various toolboxes list will be available here. Just like a MATLAB, Simulink, 5G tool. Any challenges if you have, then please let me know. Okay, whether my voice is audible or anything, PPT is not visible or my slide is not visible like that, please let me know. Okay, I'm audible. My this MATLAB window is visible.
Yes, yes, audible, visible.
Okay, okay, fine. Thank you. Thank you very much for replying me. So this is a toolboxes. Just if you pass a command VER, then you have a MATLAB, Simulink, 5G toolboxes like that, auto space, toolbox, antenna, audio, bioinformatics like that. Here we are going to explore curve fitting toolbox. This toolbox today we are going to explore. Okay, and then we have further toolboxes available like data acquisitions, deep learning toolbox we are going to explore. Okay, so these are the things we are going to do. And then you have image acquisitions toolbox, powertrain blocks. If you are working on the electric vehicles, predictive, these are satellite communication toolbox. Okay, the sensor fusion, signal processing toolbox. These are the whole. I have downloaded all my toolboxes which I will. Then I will show you statistics and machine learning. It's AI toolbox where the AI toolbox is available. Like if you go to the S, in the statistics and machine learning, it is available, and along with the deep learning. Okay, so here signal processing. So if you go to the statistics, yeah, it is here. So here I'm going to talk about using this statistics and machine learning toolbox today itself. Okay, fine. So these are the just small introductions. What we have first. Okay, then pass a command CLC. Okay, so it will clear. It will clear the things. Okay, so just pass us some, let us see that some computational power of the MATLAB, like a, just pass a 10, answer will be 10, like a age equal to 10. Okay, age equal to 10. Then again, then just simply type age equal to 10 with the semicolon like that. Okay, so now see that I quickly take this. So you may find out what is the difference between these three. So we quickly move further. So this difference is like that the semicolon, the output will not become, then If you put age equal, then A will turn. If you cannot assign any variable to the your numerical value, then it will store in the ANS like that. Okay. Now, if you pass a command, next command we are going to learn who. These are things are required in future. Who. So who will tell you what are the different data types you have in your workspace. Okay. So you may say that the sir only data what are the different variables are available. You will get to know by the who command. Let us pass another command whose, whose will give you all the details of your variables which are available in your workspace. Okay, so here you may find out here double tables. Okay, so here A, N, S, C data. These are the our variables which are available in the my workspace. Fine. So let us see that. So these are the things are there. Simple numerical computational we can do pi, the simply type of pi, then pi's value like that. Okay. Now the you might be know that how to create a matrices like A is equal to, let us suppose you want to create a row vector, then 1 is space, 2 is space, 3 like that, and enter. So row will be created. Similarly, the z is equal to, let us take the z, and this is a square bracket. So one by one, I'm jumping on the numerical computational part. I'm jumping to the array part, how to create a row vector array, some fundamental things. Then I will jump to the some AI part. Okay, so in that way, I'm heading my session. Okay, so now see, you have to create a row vector like that. So you use the comma between the consecutive elements, again comma, then 3 like that. So you will get the same answer. Okay, either you can give the space between the element or you can make a comma like that. So you will know these things. Now others, again you have to create a column, then 1 comma 2 comma 3 like that. So very simple. So you can create a column vector. So again, you create a value A or whatever. A is already so many times I have taken. Let us take the G. And now manually you can create the 3 by 3 matrices. 1 is space, 2 is space, 3, semicolon, then 4, like that, 5. Any numbers you want to give like that. Okay, so when you enter, then you have a 4 by 4 matrices. Okay, so some standard functions are also available to create a matrices. Let us pass a command magic in. Okay, just pass a command magic in under the parenthesis, just pass a command row column only one digit. Okay, so it will give you the one match number directly 3 by 3 matrices. Okay, so you can say what is a main here, but any can find out in this number what is the magic behind the magic. Anyone can say me, unmute and tell me. So what there is a magic behind this magic. Okay, there is some patterns are there. If I pass magic 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 4, then there is a also there is a some certain pattern. Okay, so here just see that anyone can find out. You can parallelly, if you are open your MATLAB, then you can also parallelly pass these commands. Okay, so it will give you the very good hands-on exercise also during this small period of time. So that's the magic 383. If you do not have it downloaded, then download the app, open the account. I think all of you have opened your account, the process I have told, and then just pass this command also. Okay, app, you can download the app, and through the app also, if you do not have a laptop at the moment, then you can do from that side also. Okay, fine. So let us see. Anybody can tell me what is the magic behind this magic? Just observe these numbers. You can find any pattern, special pattern in this. That's why it is called as a magic. Okay. So just pass magic.
Random number.
Okay. One answer is a random number. Fine. Any other thing? Of course, it is a random number. Any other observation?
Random number of size that number we have entered into the magic number.
Okay. Any other things? That is okay. That is a magic. If you find out here also. So okay, fine. So interest of a time. So if you add these three numbers, and you can add these three numbers, sorry, this row and column number, you will get the same number. Just add it 3 to 1 and 1 to 4. Okay. So magic number magic under this 816 and 834. So it will the 50 number. So any row and column, if you add, then you will get the same number, like 8, 1 and 6. It's a 15. 8, 3 and 4. If you add it, you will get the 15. 3, 5, 7, 15, and then 3, 4 and 8, it will 15, like that. If similarly here also 1, 5, 6 and the same row. Row and the column, if you add it, then you will get the same number. This is the magic behind the magic. And thanks for participant for giving me the answer. Okay, so the 16 to 313, if you add it, you will get the same number. That's all. So this is the magic. Now you have a lots of things. Pass a ONES once row and column. Pass a column, one row and one. That simply I will take it just. Okay, so now zeros. Zeros. Because one I have taken, so 3 by 3 I have to take. Only one element I have taken. So that's why it is a 1 over here. 0, 0, 0. Okay, so like that you can create a matrices by the single click. The 0 is a function. Okay, just remember that 0 is a inbuilt function which taken by the programmer at time of the MATLAB when it is developed. Okay, so anything before this parenthesis is generally it is a inbuilt function. Okay, fine. Similarly, another function is a random number. I want to create a random number. So another function is a rand, and then you have a parser command 3, 3, and then it will give me the number which is a between 0 to 1. Any numbers they will take between 0 to 1, and they will, if you pass a command and then pass a command 3, 3, then you will see that it's a whole number, like that. Okay, fine. So let us suppose I want to save it on the sum of the number m. Let us suppose m. I want to store in the RAM and just create a 3 by 3. Any This is the matrices I want to create. Now rank I want to find out the matrices which I have just now I have created. Just I will take, so rank of m, so it will 3. Now I want a determinant of the my matrices, so I just pass a and like that. Very simple. So we can do like things. Okay, so this is just for the understanding. Now jump to the colon operations. You might be know these things. Okay, so 1 colon 10. Okay, like 20. So use the colon operation to create the numbers on the x-axis. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. If you pass a command 1 colon 20, then you have a number 1, 2, 3, 4, 5, 6, 7, 8. Okay, so each next number is from the previous number, it is a 1 increment. Okay, so 3 is incremented by 1. Again, 4 is incremented by 1 to the previous number, like that. So that number you can create. Let us suppose you want to create by your own number. Increment should be done by your own numbers. How you can do that? 1 colon your number, your desirable number. Let us suppose 3. My desirable number is 3. I want to increment, and then pass a on last number on which you want to go. So like that. So here each number will be incremented by 3. 1 plus 3 is 4. 4 plus 3 is 7, like that. So this is the format everybody know well. Okay, fine. That is a thing. Colon operation. Let us do again this class. Okay, let us suppose this is a matrices which is saved in the ANS. I want to change the value position of this pass a command and the position of that number which you want to change or manipulate. So you just pass a command 1, 1 and then equal to which value you want to change, just enter. So this matrices which was there, by this action it will changes with the value. So basically you have to define the matrices first on which the matrix stored and position of that number of the matrices and equal to by which number you are going to change it. That's all. So here just see here. So 1 will be replaced by 100. That's all. So this is called as a matrix manipulations, CLC. Okay, colon we have understood. So now just create 0, 0 colon 5 by 10, 5 by 100. Let us suppose again colon 2 into 2 into 2 into 5. Okay, just save it in the T is equal to, make a semicolon. I do not want to see my answer. Okay, now create a Y is equal to sine of t. Just quickly, I will cover this part. Okay, so because I have not make a semicolon, then it will execute it here itself. Okay, so that's why this come. I have not make here semicolon, so that's why y has executed here. Okay, but I do not require these values. Should be replaced, display on the screen. Now my interest is something else. Plot function I can use. Make a t comma y. So t comma y. Okay, so this is a plotting functions. I use the plot as a function to plot sinusoidal waveform. So this is a sinusoidal waveform. Okay, so I plotted through the command window. You in the MATLAB you can write a code in the three places. One place is called as a command window itself. Another place is a script. Another is a live script. Okay, so you can write a three-way. One is a script by just making a control N, and its extension is .m. Okay, and the live script, which is a new one, you can write a here. You can write your all the code in the live script. Its extension is .mlx. All the current examples, documentations are in the form of live script. Most of them, 90%. Okay, you can find out all the examples in the MATLAB is in the form of live script, which is very easy to use. It's just like your notebook when you are preparing or professors are making a notes, just similar to that only. Here I have to define by the making a comment sign. Let us suppose I want to define this function. Okay, so what can I do? I have to write it again, and now I have to make a comment. I have to make a percentage sign here. Okay, and then I am able to define it. This is very time consuming, also not looks good. Define. Okay, define plot like that. Okay, so like that. So this is the one, and here in the command window, if you write a code line, I have to execute line by line. Okay, so this is also not desirable. So that's why I have a one another option which is called as a script. So in the script, first of all, you have to save it. Okay, first whatever the script you have, go to the editor section. Here you have a save option. First of all, any task you begin that should be in the editor, you have to save it first. So just go to the editor tab and go to the save and save as. Go to the save as option. So I have already created on the desktop with the name of BVCOE workshop. So I went there here. Yeah, here I have already created, and I will save it here with the name like a sign. I'm going to plot it here, sign, like that. Okay, or example one, I go to the example one, like that. So there is some extension is there, you can use there should be not any function name or any inbuilt function name over here in the file name. Okay, so you have to use the underscore word, okay, or continuous, like that. So if I save this with the plot name, it cannot be saved. Okay, because plot is a inbuilt function. So that's why. So example number one, I have saved it in my VVCOE workshop folder. That's all. Everyone make it like this way only. Okay. So same way here, one number, two number, like that, and here is a run option. So you can edit anytime. Here I cannot edit. Okay. Once I write my code, but I cannot edit it because it is executed. Okay. So but here I can. That's why it is called editor. Okay, so just again type it down. Yeah, define the t, time t 0. Along with me, you also do it, pi by 100. Okay, and then again colon 2 into pi. 2 into pi means 360. And here you can make a semicolon or make a comment. Okay, and defining time, like that. Okay, similarly, again jump to the next part. So y is equal to sine of t, sine of t. Okay, so here you are defining like that. You already know this. So like that you define. I'm not interested in the explaining the editor, but I have my intention is something else. Define, yeah, sine or whatever you want to write, or then again plot function you are using, and plot t. Sorry, here in the editor it will give the suggest you. Okay, it will suggest you which the command you are going to type here, t comma y, like that. Okay, and then again you make a comment and define plot. Okay, sine plot, or plotting the sine plot like that. Here 1 2 3, anytime I go here and change the value also. Okay, now after that I just click on the run. I have already saved, but one thing more, whatever I have saved it is not in my current folder. Try to understand how to make a current folder here. So just go here. If I save it, if I run it, it will ask me your current folder. The example ex1.m is not in your current folder. Okay, it will ask me. So this is in my desktop. Okay, sorry. So you have to make in the your current folder. It should be. So I will tell you later on how to do that. So just run it first. It will ask add to path. So add to the path. That's all. Okay, it will run. So like this. So it will run here, same thing, but the same, some problem has been resolved here of the command window. I can write a code, all the once I write a code, then I will run it. And the one problem, this figure window is coming outside of the my main window. Okay, so that problem still persists. So this is the thing. Fine. So let us move. And similarly, you can do so many things. I have not given the grid, title, listen. That this again the edit the my programming file will be increases. That I think suppose you know those part. Okay, but my interest is something else. My interest is here to explain you. Go to the home tab again, and here you have an option new. Here you have an option live script. Just click on the live script. Once you click on the live script, okay, that extension is .mlx. Okay, the same thing we can do. Here you have to focus. Yes. On the editor part, just click here. You have a more focus on the text, another on the task. If you go to the editor, that is a, if you go to the home tab, under the home tab, go to the new, and new first I have explained you the script part that is already covered. Now click on the live script part. Once you click on the live script part, then you have a two options. You can write a code here, you can explain also. So like just like a notebook. So go to the text and here just define it. Plotting of sine wave. That's all. You want to make a heading, just go here and make a heading also. So title, it's become title, and then you make a first step number one, step step one, or whatever you want. Here you can write define a time, then step number two, like that you can do, make a more illustrative. Okay, fine. So then once your description part is over, what you can do, then go to the again code live editor and go to the code part. Just click on the code, and then again code part will be appear, and then just do the same thing. T is equal to 0 colon pi by 100, then colon 2 into 2 into pi. Okay, simple. That's all. Okay, make a semicolon here again. You want to make a section break, then you can do the section break also. Means section break means you are turning your page of your notebook. Okay, that we also do. Y is equal to sine of t. I'm defining the sign also. I've already explained this code in above step number 1 and 2, like that. Now after that, then you have to plot it. Okay, so use the plot function. Plot t comma y, like that. Okay, and to run this live script, here you have option. When the cursor will be moved on this shadow line, do not click 1 2 3, this one. You have to click on this shadow line, otherwise you have to click on this run. Okay, so anyone where you can click. I generally prefer this one, so just click over here. Okay, now see the difference. Here you will get your answers. Okay, in the same page your answer is available. Here my code and answer in the same environment. Here is a sine wave. You want to change answer is below my code, or answer is adjacent to your code, or answer means output I'm talking about. Output is adjacent to your code, then it will be here. You have to click on the right side or in a line. That is a, you can select from here. Here is options you have. Okay, fine. So these are the things we can do here. Okay, and you can writing your describing a code here also. You are writing a code here, and answer is also here, and other further things are also you can do. Just select this graph, and I have not given the X level, Y level. If you just click on the X level, automatically X level template will be open. If you click on the Y level will be open. Title, grid, like that will be open. Just on the click on the grid. Okay, if I click on the grid, just see that behind the grid will be automatically appear, and the code I have to update grid on. So just update the automatically it will suggest, and click on the update the code. Automatically the grid on will be in your main code, it will appear. Okay, so it means that automatically it's updating the code also. That's all. Okay, for this one. Let us suppose you want to do more things. So let us suppose you want to do animation to the this waveform. So how we can do that? So go to the task, go to the task option. Here in the MLX file, you have a lots of capability. You directly interpret the templates, app templates. Okay, fine. So just go through that, and here in the graphics gallery, you may find out it is exclusively available for the MLX folder, like create converted task, cluster the data, mathematics, optimize, like that. These are the gallery where the apps are available. At the moment, I'm interested in the graphics gallery where you find out the create a plot. Okay, once you click on the create a plot, so one template will be appear in the same line of your code. Okay, same line. Okay, so it's almost 1 hour is there. So this is a part. Now now it is a open. Now see that. Now this is the open here. So this template is open. Similarly, if you work on the optimizations, if you work on other things, then same template will be appear here. Okay, in the same line of your code. So this is a good for us basically. If you see that, now these are the different visualization, data visualizations tools are here, like a plot, search plot. If you are working with a 3D diagram or histogram, scatter plot, bar chart, okay, steam graph, smooth logs, okay, counter, like that. Here is a list of the tool, list of the.
Hello, sir. Can you please repeat this once?
Yes, yes, ma'am, please. So once this is the power of the .mlx file. So once you want to do the further analysis, then what you can do, simply, okay, I will just remove it. I remove it first. So I will do it once again. Okay, so okay, fine. So let us suppose I want to do animation to the my graph animation. Okay, so in the .mlx file, you have a this option, task option. This is exclusively available under the live editor tab only. So under the task section, you may find out these are the templates. You can do your task. Okay, like optimizations, visualize the PD result, reduction dimensions, cluster analysis. Okay, data import if you want to do. Okay, now you have to do pre-processing of data, cleaning the missing data. The direct template will be appear over there. Okay, fine. So these are the things. Control system, under the control system, tuning of the PID control, direct on template will be appear over there. But at the moment, I'm interested in this in graphics gallery. Go to the graphics gallery and click on the create a plot. Okay, so if you click on the create a plot, automatic here under the where my code is finished, here one template will be appear. This template. So this template will be appear. So just see that this is a create plot visualization of the things. This template will be appear, and with all the 50 plots which are supported by the MATLAB will be available for you. Okay, so if you want to do anything, if your plot is like a scatter plot, like that. So let us suppose I have to do that, and you can select this out of 50 plot. You want to select it. Okay, so here you have option animations. You want to do animation, counter plots, control toolbox plots, data distribution plot, discrete geographic plot, images, line plots, polar plots, signal processing, statical visualization, surface or mesh plot if you're working on the 3D diagram. Okay, so these are the things we can do. So I'm more just now I'm interested in the animation of the sine wave which I just now I have created. So just select the animation. Once you click this animation, out of these plots, these three are supported. There's comment 3. If you have data is the 3D trajectory, but my data is a 2D trajectory. I can use this one. Okay, so I just select this. Once I select this, it will ask the X and Y option. So just go through that. In my, what is my X? X is a T. You can use X as X. I have created X as a T and Y as a Y. Just now I have here never one. Once I pass this X and Y, then code will automatically run here. It will be unnecessary. Script is running. Okay. Once I will pass this, then now see that this animation is created. This animated file of my plotted graph will be created. Okay, you can increase the speed of the animation also once the it will run. So just see here, it will be again, I'm not able to close at the 4:30. It will take more time. Okay, so let's see here now. This animation is completed. Once this animation is completed, you will get the speed also. Okay, here you have a different playback speed like 2x, 1x, 0.2x, 0.2x, like a 2x. When you place on the 2x and just run it again, so it will be very fast like that. Okay, so you can do that also. You want to save it also in the, if you click over here, then it will be saved. Okay, you can use it for your own work on your project or your work or paper. Okay, so here you may find out MPEG4 format. Okay, here you have a two format available, I think video format AVI also or .gif also. Okay, you can save it for the at .gif, .avi or .mp4 as per your requirement. You can save in these three format of this your work. I'm not saving here, just for the explanation purpose I have explained you, and it will save in on your desktop and from where you can use it in your PPTs or in your live class also. That's all. So this is the capabilities of the MATLAB. Madam, I'm clear here. Understand this
Yes,
part?
sir.
Okay, thank you,
Yes,
ma'am.
yes, sir. One more thing is that
Yes, yes.
with us, if MATLAB 2024 is not there, lower version we are using.
Okay,
I'm using here 2018 B now, but
okay.
I guess I'm not getting that option that directly
Yes.
control
Hmm.
and task option is not there.
Yeah,
So
correct,
in that
correct.
cases, how to do it?
Yeah. Thanks for asking me this question, ma'am. Ma'am, this as a live editor option is available after the 2018 onwards. Okay, so higher version like the 20, as you know that in the each year MATLAB will launch the two version. 20 in one version will launch in month of April and another version will launch in the month of September. A and B format. Okay, as you are using the 2018 A, in that year these options are not available, so you have to use the higher version of the MATLAB. If you are using the customer of the campus wide license, then it is available 2006 onwards till today, and that is a 2024 A. You can use it from the your login page. Okay, so in that 2018, these two options are not available. It is available in the higher versions, which is above the 2018, like a 2009. I think 2020 it is available. 2020 A, 2020 B, like 2021 A, 2021 B, like that. 22 A, like that. So in 18, it will be not available. I think so.
Yes, sir. In 18, it is not there.
On that
Only
release, it is
code
not
option is
available.
there.
Yeah, task option
Uh,
is recently it is a join. It is a recently have come. I think 2022 it is as launched this task.
okay,
Okay,
sir.
fine.
Yeah,
Okay,
fine, sir.
fine. So if you want to use, then you have to download the higher version. That's fine. Okay,
Okay, sir.
now
And
I'm using. Yeah, yes, please, ma'am.
in same one, I have that other options like that for the plotting, all that optimizers and plots and all that are available, like histograms.
Yeah.
These are
Okay.
available here, but how like curve fitting and everything is there in 2018.
Hmm.
How I can use that animation part in 18? Is it possible to use the animation part in a 2018? Because now I am
Maybe
using a
some other
laptop.
functions are available in that part also. It may be available. We have to find out. Means animations are maybe available. That functions are available in 2018 also, but it may be in the other format. We have to find out. Okay, because I'm
Oh,
using this 24A very extensively. So 2021 onwards extensively. So I have an idea about that, but it may be available. As you have to search on the this documentation. If you search here documentation, or simply here, if you go to the that part, I will tell that part also, DOC part. So here you maybe search, then maybe option may be available. Okay, if you want to use it. Okay, let's move further. Hopefully I'm clear your doubt and the
yeah,
answers.
yes. Thank
Now,
you, sir.
okay, fine. So okay, fine. So these are the some basic stuffs have been completed. So we have till now, what are the things we have covered? We have understand the .mlx file and its capabilities, and then use .m file and other things. Okay, fine. So now move further, and under the this. I will explain you some more basic stuffs. Not basic. Let us explore this part, app. So plot is over, home is over, plot is over, and then come to the app. If you go to the home tab, these are the apps are available. App mean as an engineer, you have to more focus on the application rather than only writing a code. Okay, only writing a code not save my time. I have to use such a platform or the work framework that the it save my time. Okay, so engineer more focus on their application part. Coding part will take care of the MATLAB itself. This is the definition I would say in the my terms is the app. Okay, here you have app. Lots of apps are available under the MATLAB. You find out these are the apps: data cleaner, then machine learning, deep learning. Throughout 3 days, I'm going to explore these apps: machine learning and deep learning apps, classification learner app I'm going to explore, regression learner app I'm going to explore, then deep network designer app I'm going to explore. These three things. Okay, so app is the very special place in the MATLAB. Now similarly, if you are the control system part, then you have a this PID tuner, then you have a system identifications tool that it will give you the directly the transfer function of your experimental data, like that. Then you have a simscape where you can build your battery building and the other things are there. Okay, like if you are the signal processing enthusiasm, then you have a here and lots of apps, signal labeler app, then you have a signal analyzer app here that you can do it very easily. Okay, another similarly another things are there. Let us explore the curve fitter app. Simple, just explore it quickly. I can explore, and then I tell you the capabilities of curve fitter app. Okay, because I have a 3 day time, so I'm moving very smoothly. So everybody must understand the maybe no, there's some other new things they may explore through this. So I'm just opening the my record fitter app. So where you have a data and then you can get your mathematical equations with the fitness of goodness. Okay, so this is the it is a goodness. This is the all about the curve fitter. Okay, so just see here. I'm just opening here. 2 3 apps today we are going to explore. This is a that series. It is the first one, curve fitter. You might be explore in your time. So yeah, this is the open. Okay. So in the command window, you have to just pass. I have a inbuilt data. I'm using the inbuilt data, and then I'm just this is a curve fitter. Here you have to open. And here you have different types of the fit type, like a polynomial, exponential, logarithmic, Gaussians. So it's very useful for the PhD students, the research scholars. Okay, you have to go to just new. Okay, or the new session. Just click on the new session. I have already loaded the two data. So I have a two data with me. I will explain you just a minute. Just go to here. I'm just uses the. There is no need of this. Okay, just a minute. I have uses the. I have uses this. I have uses this census data. Okay. So census data I have uses. It is in the form of .mat file. Okay. So it has a two options. You have a one population. This is the population data. I have just loaded this data. This is 1719, 1800, 1810, 1820, like that. This every 10 years they have selected. They have measured the population of the San Francisco city. Okay, and then you have another C data and the pop. The pop will be here. Okay, and this is the respective populations of that respective years: 3.9, 7.5.3, 7.2, 9.6, 12, like that. Okay, so this is the way they have measured these two data. So for this, I have just used this load census.mat. You can also do that from your side also, and then use this. I don't know about that. This, if I show you this is data and the population data, these are the data, but I do not know in which way it's increasing. What is the mathematical equations of that? So here the curve have come into the picture. So you have just simply click on the new. Once you click on the new, what happened? Once you click on the new, go to the new session. Go to the new session. Just I'm explaining the one this part. Once you go to that part, and then okay, it's already open. No, not open. Okay, just a minute, let me check. Just a minute. Okay, now once this new session is open, now click on the select data. Okay, once you click on the select data, I have already loaded my data in the workspace. And now give your name also. If you want to give here name untitled fit one, by default it will come. If you want to give any population or whatever you want to give, so just give. And the x-axis, what you want, and the date. Generally the date is there on the C date. And then on the y-axis, I have selected the x-axis as a C date. Okay, and the y-axis the population. So it is in the form of pop. Okay, which I have just now I have shown you in the Excel sheet. And close this because Z is not available, so there is no need to upload the Z. Now this is this line, blue color line is a fitted line. By default it will come in the polynomial of the degree 1, I mean straight line, and this dot 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 line is our fitted. I have this is my data line. Okay, so which I have, this is my experimental data dot 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 line, and I want to fit to this straight line. Okay, so how can I do that? So I just increase the value. And here you have an option polynomial 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Okay, so let us see that. Let us do polynomial is suited best for this or not. Let me check. Just increase the polynomial. Under the polynomial, you had up to the ninth degree. You can go ahead with third degree, 4, 5, 6, 7, 8, 9. Okay, so on the second, it's almost first. Now whether is a good for me or not, here you have a fitness of goodness, SSE, RA square, DFE, adjacent RMSE value you will get here, and ultimately it will come over here also. Later you are not satisfied with that, then you have a lots of options are available. Spanning the that is also you can do. If your own equation you want to make, that can also be interpolate you can do, and the available and power rationals logarithmic, like that. Okay, and then if you are satisfied, and then you can compare with the two polynomials in the form of fitness of goodness. Okay, you can import your Excel sheet also. Okay, and then you compare, and you make here duplicate. Let us take the duplicate. Okay, just click on the duplicate, and then same data set. I will go for the I will go with the another way, like a Fourier. I will go with the Fourier analysis. Okay, with the Fourier, let me check what will the changes are there. Okay, so it's running, and here you have an equation also. Here you have equation like a0 a1 cos b1 sin phi. That is a standard equation under the Fourier of polynomial y is equal to mx plus c, and its coefficient values also be available for you. Lower and upper value, its mean value is here, and lower and upper value, and its fitness of goodness value is also there. Okay, so under that first degree, and you can compare here This first one is a quadratic, and second one is the copy, that is your Fourier, and you can compare the fitness type, R square, what is R square value, then SSC value, and then DFE and other things. RMSE value will be changing, okay, and coefficient 3 and 4 like that. So you can compare with the different fitness. Okay, so this is the one app, and you can click here if you want to generate a code behind that. What are the code is available? So just click here. You can generate the code also, and you export the figure. You want to import to the Simulink lookup table, then can also be done. That is a simple part. So hope so from these demonstrations you have understand how to use the Anchor Fitter app, okay, and how to compare the data. Okay, fine. That is a more than sufficient for the this understanding the live editor and app part. Okay, similar you can add here. This is an example. You can put different graphs here like that. You can put here, and then here the results, and here drop down menu you can make. Okay, so these all the things can be done in the in the uh, in the uh, in the live editor very easily. So I highly encourage that all the participants can use the live editor more as much as possible. Okay, so now switch to the next slide. Yeah, we can divide code into sections, embedded next code like that. I have already explained. If you want a PDF file, then you can save in the form of PDF also, or Word, HTML, or LaTeX also. Okay, your all the code will be saved. Then these are the template, as the madam is asking me that how to incorporate these tabs. Okay, so live editor tabs are there. All the things can be done in the live editor itself. Okay, these plots we can do it without writing a single code. Okay, so let us start. Okay, this time to let's handy. So let us jump to the our AI part. Okay, is there any challenges? Yes, any challenges you face? Any problem? So now we will switch to the next part. So I have a further 45 minutes with me. So during these 45 minutes, I will explain the machine learning part, AI part quickly, because I have an app or some data visualization technique I have. That part I'm going to cover. Yes, participants, shall I move further?
Yes, sir.
Okay, fine. Okay, so what is, let us see the AI, just explore the AI part. Okay, so what is the machine learning basically? So let us start with this something else. Just a minute. Okay, let us start the AI. As all of you know well, that the program that can sense, reason, adapt, and adopt. Okay, like a human. Okay, and that to mimic like a human intelligence or human behavior, the machine can learn. So we have a two portions, machine learning and deep learning. Okay, so machine is a subset of the artificial intelligence, where you work on the automated driving and drone delivery package of Amazon or anyone, Flipkart, like that. They are using the drone delivery, or these just see the examples of the robots, humanoid robots. They all are the examples of the autonomous system. So these all autonomous, what is the brain behind this all autonomous system is the AI. Okay, AI applications or AI algorithms or AI things. And there is a further, we have a machine learning and deep learnings. So basically machine learning is artificial intelligence subset which it automatically learn and improve from the experience without giving the explicit program. Okay, or it is a data driven modeling. Generally we do the modeling of the mathematics. We apply the physics. Okay, I have to model like F is equal to ma. Okay, Newton's second law or first law or the third law. Okay, so I want to model the mathematical equation. But when the data is not, data set is very large and mathematical equation cannot be made, where and you want the get good insight from the data, then data driven modeling come into a picture like a BMS, like SOC estimation of the battery, okay, state of charge estimation of the battery. On that, so many things are there. So data driven modeling is the come into the picture. So this is all about the machine learning. Let us explore one by one. There are the two way you can do the program in the MATLAB. Okay. So one you have a data and program. Okay. Traditionally, what we are going to do, give the instructions to the my computer, that data as an input, and feed the program. Then my computer will execute the data in the program and it will give me the output. Okay, so this was my traditional way of programming. But new way of programming is the this one. You have an input output both, and your system will generate the program for you to get the desired results. Okay, so this is the machine learning. This is a slightly change. You have input output data both, and then you make in a such a way that your program will be program is ready. Okay, program is a output, as a output, I would say that. Okay, so where to apply the machine learning? So this is the basic idea, and where to apply the machine learning. Okay, which is a AI part. So AI machine learning is everywhere. So where the equation cannot be formed, first thing, where this like a speech recognition, object recognition. Okay, where the solution is too complex to write in the form of equations. When it happen, when we have a non-linear complex relationship. Okay, in that case, the machine learning can be applied. When the our solution needs to adopt the changing the data, means my equation must be changed with the changing data. Okay, so when data set is very large, like a weather forecasting of the whole India, or the energy load forecasting, or stock market predictions. Okay, in that case you can apply the machine learning. When you have a very large data sets, like the taxes ability, IoT data analytics of the any smart cities. Okay, sensors data or weather data is coming and you have to analyze. Okay, so there is a number of feeder points are available, or airline flight data analysis, or airline flight delay analysis we have to do. When the learn the effectively from the very large data sets. Okay, in that case you can apply the machine learning, and machine learning is available everywhere. Okay, we can apply machine learning application everywhere. Okay,
so we can work as a team. We can work as a team to tap on the expertise we have got. We can look around the various things, various technologies, various types of data, and then we can we can do some scoping of some.
yes, yes, what happened? Then I have a type of machine learning. Okay, so this is a machine learning type. I think time is available now. Yes, organizer, the time is available for me, as you told me that types of machine learning is that the two types of machine learning. So unsupervised and supervised learning. Then you have a first under the
Yes, time
unsupervised
is
learning,
available. Yes.
clustering, and then you have a when you have a only input data. There is when the only input data is available with you. So my mechanism or my machine learning algorithm learn the internal hidden pattern and give the outputs. Then you have a two options here: k-means or Gaussian mixtures. Okay, so segmenting the data into the groups based on data similarity. Okay, hard clustering models, soft clustering models. Okay, so discover the patterns within the data sets. Okay, check the outliners. So these are the things can be done in under the supervised learning, where you have only input data. And the when the you have a input output both the data, then it falls under the category of supervised learning to develop the predictive models. Okay, so first it will come under the regressions under the supervised learning, and the second one is called as a classifications. Okay, so these things we are going to explore and my webinar today. So let us see anything we are going to cover, regression or whatever. So regression I'm trying to cover today. Okay, later on we will jump to the classifications. So everybody, regression is the really interesting. So we have a further algorithms in subdivided under the regression like support vector machines, discriminant analysis, nearest neighbors, and you do the neural networks as well. Generally, the neural network comes for the deep learning, but the regression also we can do. Okay, and then similarly for the classification, you have a discriminant analysis, nearest neighbor, and these are the in the MATLAB. I think 27 sorry, algorithms are there for the regressions and classification. I think 36. So on that, which is just best suited for you, we have to identify when we train our model. Okay. So this is all about the machine learning with the MATLAB as their classification, all those things. Okay, fine. So what are the different apps are required? So let us jump here. So I'm going to start with the regression analysis. Okay, so I will do with the one demonstrations. I went to here. So very simple with quickly time. It's a very not very fast and hard rule here. Just basic understanding, and you can start the model even though you have a very less programmatical knowledge with you. Okay, so this is the application of app. Okay, that's all. So this is my view. You can do if you have to more focus on your experiment. Okay, first of all, I will show the my data set. Okay, that data set I want to explain you. So that is important. And then I will start with this part. So just we take 2 minutes break. Okay, just 1 minute or 2 minutes break. Okay, I will start at 4:30 sharp until 5 o'clock. I will finish. Okay, this 30 minutes I will completely dedicated to the regressions. So just take 1 or 2 minute break. I will start at 4:30. Okay, is it okay?
Okay.
Okay, 2 minutes break for the participants. Okay, welcome back. I'm taking a 5 minutes break. Okay, fine. Let us start this part, remaining part. Okay, so yeah, I'm audible. Yeah, fine. Just sharing my.
Sir, audible. Audible,
Yeah,
sir, audible.
yeah,
You can
yeah.
start.
Just yeah. So now see here. This is my app. I just went to the machine learning, deep learning part, and I will click on the regression learner app. Once I click on the regression learner app, so one interface will be open. Okay, so before that, I have to explain that data set where I have stored it. This one. Yeah. So once the regression learner app will be open, then yeah, then I have a this exercise file. This is my data set. Okay, vehicle data. Let us explore this data first. This is the data set which tell us about the car or truck. Okay, so where the car has a engine displacement, rated HP, transmissions, weight, okay, compression power, then axial ratio, EV speed ratio, whether this working on the uh, highway or city, or how much CO2 emission is emitting, and mileage. Last column scheme is the mileage, 43. Okay, so car, this is the data I have taken. Okay, similarly, you can also do your own work, and similarly, you can apply this task here. So this is the data. It's around 2000, 2300 column, sorry, rows. Okay, so just find out here. Yeah. So 2338 column is available with you, and this is the for you. So car engine displacement, rated SP L4, weight 9.8, 2.69, 39.2, highway. These are the data I have. Okay, so whether the car, truck, okay, similarly, the truck is also there. So this is all about my data set. I have to predict my mileage. Okay, so this is my all about my data set. Now I have already opened my regression learner app. So regression learner app is already open. Now under this app, just click on this. You have an option how to import the data. Okay, to this regression learner app. So you have a two option. You can start with the workspace or from the file. So anyway, any two options out of these two options, you can use any one option. So I'm explaining through the file only. Okay, so just click on the file. Once you click on the file, go to your file destination where you have to save it. I've already explained you that in the previous workshop I have under the code, under the ML, under the exercise file, regression model, and vehicle data I have. So I just upload this. I just uploaded my data by clicking on the new session. Okay, so this is opening of this spreadsheet. So similar to the yeah. So any question? No, not a question. Okay, fine. This was 100. Now it is 93. Okay, fine. So now the same model has been here. Okay, so this is the imported. You have a lots of options, table and all the things. Okay, now just click on the same data set, the car, truck, displacement. Now click on the importer section. Once you click on the importer section, then okay, so importing a session will be started, and automatically. So last column is the our response, and the other one is the predictors. Okay, so car, truck, displacement. If you want to change that, you can change accordingly. Okay, so you have here 2 2 2 3 3 7 cross 11 tables are available. columns and these are the rows. Okay, and you have on other right hand side you have a cross validations your data. So here you have a predictors, here you have a response, and then you can click on the start the session. Okay, once you click on the start the session, this upper one, all the tabs will be able. Okay, which is earlier it is a disable. Okay, so by default, here you have a lots of options. This is a parallel computing tool that is used parallel. Okay, so means it can be divide your whole data set into the virtually cores. Okay, like a 4 or 6 cores. Okay, if your machine is only single core or double core machines, your laptop, then the use this automatically it can divide into the multiple core and it boosts your speed of time, computing time. Okay, now here you have options getting started. Here you have a regression, linear regression models. Here these are the options are available: linear, non-linear. Then you have a regression trees, fine tree, medium tree, coarse tree, optimizer tree. Then support vector machines are also linear SVM, quadratic SVM. Okay, like that. Then efficient trained linear regression model, Gaussian process regression model, like that. So these are the all the models are available. Let us see that on which model my for my best suited for the my data set. Okay, then you have here options available: PCA, principal component analysis, and then optimizer is also available for your data set, whether you are surface gradient or the other optimizer, Bayesian optimization you want to use, grid search or random search. Okay, like that you can optimize your train model. So these are the options are also available. Okay, so what I can do, I can click on the all, or I can quick train to quick to all. Okay, quick train to all. Okay, so this has a randomly they have selected around 10 models. Okay, and they train your data set to on that selected models. And either you can select the all also, no issue in that. If you select all, then you have to wait for the time and just click on the train all option. Okay, once you click on the all, and after that you have to click on the train all option. That's all. So once this step is over, it will take some time because the around 29 models are available. Okay, so after that it will take some time to train all models, and it's in the queue. Which is the best model? It's come under the box. Okay, to save my time, I can select any one model, but I have selected the train all options. Yeah. So here is all the models are available. Just here, all are in the queue. So tree, linear regression, other type. Then the robust linear, stepwise linear, tree, medium, coarse, linear, like that. It is going on. Gaussian process, assembler, neural, kernel, like that. So the training is under process. Okay, so here first train is over. Now second one, third one, like that in sequence, one by one, it will go ahead. It will not be like that. The last one will be trained here. Okay, so total 20 models are available for the regression. So the one by one, it will be train all. First, to save my time, I'm just selected this as a best model, the tree model, like that. So just see that. Just click on here. If I click on here and then see the summary. So here you can see the summary: RMSE value, R square value, MSE value, MAE value. You can see here training time. You can see model size. What is a model size? Okay. So everything is, we can do that. Still training is going on. So to save my time, I'm just selected any one train model. And then after that, here you have option. So response, predicted, actual, residual, like that you can do. If you click on the response model, for the selected this model, the response models are available: true and predicted. The blue one is a true value and the yellow one is a predicted value, and between them the error will be there. Okay, so if you click on the error, so between the error it will show you. Okay, for this particular tree model. Okay, if you click on the this is the predicted versus actual model. This is the think everybody interested in the if your regression analysis. So this is your predicted versus actual model, because this model is just 1.8335. So this is the our whole data set will be surrounded like this. Okay, so in the single click I have able to plot my predicted versus actual model. Okay, like that. So we have to look for the first worst model. So still 28 model under the queue. It will take some time. Okay, so train all model. So parallelly I'm explaining you also. Okay, so and now if you want to lay out, then you can do the compare the different model also. In the previous one or this one, you can compare the different models. Okay, if you want to generate a function, you can generate a function also. Let us suppose I am considering that the selected model is the best model for me. If I select here this linear regression RMSE value 3.272, just see here this model predicted versus actual value. Okay, just see that predicted versus actual value of this model. Or just a minute. Yes, all the models are getting trained. So just select this. Just select this RMSE 1.83. Okay, almost. So just click on the predicted versus actual value. So it will be like this in this situation in the tree model. Okay, so this in this situation it will be like this. So it will be plotted here. Now after that, here you may see that observation, how much predictors, what is my response, like that. Okay, so still it's under the, again take some time. Let us consider this one is the best model for me, or this is the best model for me. And now plot the predicted versus actual. I already explained that part. Okay, fine. So just a minute.
Excuse me, sir.
Yes, yes, please.
Sir, if the number of samples are less than 100, then can we use this regression analysis? Here you had almost 2000 samples now.
Yes. Yes. If you have the next example, I have a very limited number of observations. It is not depending upon the observations. Okay, if your sample is less, then the same thing you can do it. Okay, but I suggest that your sample size must be as large as possible to make your model very perfectly work. Okay, here I have observation is very large. So let us see that. If I go here and then predict the model, still it is under the training period. Okay, if this system is good for me, so let us export the model. If you click on the export the model, so if this model is perfectly fine for you under the all the means all the parameters, then you have to just export a model and click on the OK. Okay, like that.
So one more doubt.
For solution.
Sir, how can we
Yes,
compare
please.
them? Hello?
Yes, ma'am. Yes, please.
Yes.
Your
Sir,
voice is
how can we
not
compare
audible,
the
is
model?
breaking. Yeah.
Sir,
How to
how can
compare
we,
the model? Okay, fine.
yeah, based
Okay.
on the RMSE error or some other parameters?
Yes. You can compare the model to result. If you go to the result table, then you have a experimental experiment. Yes, go to the result table and then you have test, and then you have a explain. Go to the part. and then you have you have to explore like this here. Learn part still is under the process of the learning. Some part is not able to explain you because this is a disable at the moment. Okay, test. So you can compare also. It's not a very big result table. All the model can be stepwise. All the in the stepwise it is available. Okay. So here option is available just near to that. I will show you. No issue. So okay. I have to close this. So that part I want to complete and then I will tell you. Okay, so I have not loaded the data here yet. Okay, so what can I do? This folder is there. Fine. I want to save this folder any condition. So just a minute. So these are the data I have. So just a minute. Actually, I have to make this under the training is going on. Just a minute. Just a minute. Take further. Okay, I will save it from there only. Okay, fine. Okay, fine. This is my folder. So I have to save it. Just a minute. Okay, fine. This is my data set. So yeah. So just copy this destination, copy the, and then paste it here. Control V, enter. So all the folders which are there in the destination will come, and then you have to go to the add to path current folder. Okay, select this path folder because it is under the, and then add to path, select folder and subfolders. Okay, so under the exercise file, so you have to just pass a command yfit. So T will become, so you have to check with the new conditions in the regression model. Yeah, this T folder is there. Okay, so this is the test I have to open. I will to explain that part also. Open the outside MATLAB, and here I have taken in a two upper value. Okay, so this is the test data. This is my test data. Now you have to use this command because this is not available in your workspace. So you have to use this command. Yeah. That part I also explain you, ma'am. Just a minute. Use this command. Yeah. Just a minute. So you can test it with the phrase data also. Just you have to load the T value. So read table, then similarly this test.slx. So if you just pass this and make the semicolon here. Now see here, the T is available. Now yfit. I think just I'm explaining the how to use this command, train model, and then enter it. Okay, so YFIT will give you the 41.41 this model and 28.41. So just go there whether this is near to that value or not. 40.41.3 and 28.1. This is my MPG for the this type of data set. Okay, so what I'm getting here, so around 41.41, 28.41. So this is the way you can check the model accuracy. In the also, yeah, here. So this is the model, madam, you which you are asking me how to compare the each model with the RMSE value, MSE value. So this is the answer for your question. Yes, ma'am.
Okay.
Are you there? You have
Yeah,
to just click on the result table, and then the tree, regression tree, linear regression, stepwise, all the models will come over here. It is a training. What is the MSE value, RMSE value, R square value, all will become over here. Is it okay, ma'am?
yeah.
Yes, ma'am. Yes, you have
Yes, sir.
result table. You have to just click on this result table. Okay. And I have also
Okay.
show you how to compare the data with the new data sets. Test.slx, you have to put it over here and the pass this command yfit and train model like that. So this is all about my regression, and further one more examples are with me. Okay, fine. If you have any doubt about the regression, so please ask me. As madam is asked to that, I have already given the answer. And tomorrow, for the tomorrow sessions, because we are near to the 5 o'clock, so you have to go through this one. So if you go to the, if you click on the Learn MATLAB, if you just click on the Learn MATLAB, then you have a various on-ramp courses. If I think you all of you know well, so all of you. So these two things we must be complete as we move ahead. So MATLAB on ramp may be completed. Okay, similarly, data visualizations part, which is a part of our session. Okay, so you have a lots of here you may find out the courses. The very ready-made courses, self-placed courses are available. Okay, all MATLAB. Okay, so MATLAB on RAM course, core MATLAB skills. Under that, the 4 skill will come. Then clean data analysis, explore the data with the MATLAB plots. Okay, then you have so many things has been added just to just few days back. Okay, so now you have a data import and analysis, how I imported the MATLAB, then data trees and times. So I request to you, all of you, go to the my course and go for the AI part. Online course, then go for the AI part. Under the AI part, go to the AI, data science and statistics part, and try to start. I can't say that the complete this, but start this course. This is the machine learning on RAM. Okay, click over here, and the things, whatever you have doubts, all the doubts will be clear here. Overview, machine learning, classification, workflow, import and pre-process the data, engineering features, classification model, and conclusions. Okay. Similarly, we will start tomorrow a regression, yeah, classification type of machine learning. Okay, then we start with the deep learning and other things, if the time will allow. So before that, everybody try to complete this machine learning on ramp. Okay, so to better understanding, if you are interested more courses, then here the list of the courses are available. Okay, so you have a MATLAB on RAM, Simulink on RAM, core MATLAB skills, Simulink fundamental. Okay, these are the very on RAM. Like if I click on the MATLAB on RAM, and then just you have to click on the start the course. If you just click on the start the course, you can start anytime, you can finish anytime. There is no time limitations. You can complete in 1 day, 2 day, 3 day. It's up to you as your time is available. Up to that, you can do that. And similarly, you can do here. Okay. So just like a similar structure, just like a MATLAB, environment. The same environment is here also. So I just try to explain one or two command and then we'll stop this. Okay, so it's setting up the course. Here your name will come. Yeah, so it's just like here you have a task and here you have a workspace and here you have a command window. Okay, so you have to focus only on this. You have to focus only on this box task. Okay, and subsequently you have a next task, next task, next task. So first task is saying 3 into 5. Similarly, you have to do for the machine learning also. You just enter. Okay, that's all. Then shift. Then you jump to the next task. So m is equal to 3 into just similarly, you have to complete all these tasks and then enter. Okay, so it will, if it is a correct, then it will be jump to the next task. Then give the space bar. Okay, like that you complete task number 4, 5, 6, 7 and other task also. Okay, so here your progress will be come over here like that. So just exit from the course for the interest of the time. Okay. And once you completed this task, you have you will get this certificate from the MATLAB directly. So view the PDF like this. So this is the certificate you are going to get it. Okay, so here your name will become how much percentage you have completed. It should be 100% and below your date will become over. Fine. Okay, so and if you want to download the progress report also, what are the things you are learned under that certificate self-driven course? So here you have that part also. Okay. You have a overview 0% like that. So everything is here. That's all. So I expecting that similarly you can go for the machine learning.
तुम्हारे सिस्टम पे सेव तो है ना फाइल? तो
yes,
तो अभी कर दो, क्या दिक्कत है? घर जाके क्या करोगे? फिर चाय पियोगे, फिर ऊपर जाओगे, फिर थक जाओगे।
म्यूट कर लो।
क्यों?
Yes, everyone, thank you. This is up to me. The machine learning, you have to complete this. Okay, so hope so tomorrow at least 50% all the participants must be complete here. Machine learning on RAM, just similar to the MATLAB on RAM. From my side, so I will stop. Any questions do you have, then ask me. So then I will conclude the day 3 sessions under the webinar series. Okay, tomorrow we will start with the classification learning app and some more part of the deep learning part. Okay, and similarly we head with the last day also. So this is a task is for the first. This is the task for the today. So try to complete it. I'm not saying that the 100% you can complete. Here you have a options. Here you have a hint. Okay. Here you have a hint. Help of this hint, you have to complete this task. That's all. This is a logic. You have to complete the task here. Before that, you have a knowledge about the MLX file, .m file like that. That's all. Is there any doubt? Please ask. Otherwise, from my side, it is over.
Anybody has any doubt, please ask. Okay, I think, sir, nobody has any doubts.
Okay, fine, sir. Thank you.
Okay. Okay, thank you, sir, for today's session. And we will meet tomorrow at same time, 3 p.m. Okay?
Okay, Deepak.
Okay, thank you. Okay, I thank you all the participants for being. Yes. I thank you all the participants. I hope you the sir which has given the assignments you have to solve. If you are try to solve the assignments given by sir, and I'm going to end the session, and I'm going to share the feedback also in the WhatsApp group. Okay, thank you. Good evening.
Sir, can you share today's recording, please?
Yeah, yeah, I will share the link of all the recording
Yes,
after
sir, please.
the FDP is over. Okay.
Okay, sir.